Welcome to PreMath. In this video, we have got this quadrilateral ABCD, as you can see in this diagram, such that this side length BC equal to this side length CD, and it is also equal to this side length AD. And moreover, this angle DAB is 6x, this angle ABC is 9x, and this angle BCD is 12x. And now we are going to find the value of this angle x. Please don't forget to give a thumbs up and subscribe. Let's go ahead and get started with the solution. And in order to solve for x, we are going to draw some auxiliary lines. And in this next step, we have connected these points B and D. And as a result, we got an isosceles triangle BCD, since this side length equals to this side length. And now let me go over a basic concept about an isosceles triangle pretty quick. And here we got this BCD as an our isosceles triangle, since these two side lengths are equal. And if we draw this perpendicular CE onto this line BD, then this perpendicular CE is not going to be the angle bisector, but also is going to bisect this BD into two equal parts, DE and EB. In other words, if this side length is lowercase m, then this side length is going to be a lowercase m as well, and this side is going to be lowercase a, and this is going to be lowercase a, and this angle is going to be equal to this angle. So therefore we have drawn this perpendicular CE, which is our median. Let me go ahead and call this side M, then this side is going to be M as well. And since these two sides are equal as well, let me label this as side A, then this is going to be A as well. And moreover, this median is going to bisect this angle into two equal parts, this angle and this angle. The whole angle is 12x, so this is going to be 6x, and this angle is going to be 6x as well. And one more thing, all these side lengths, this one, and this one, they are equal. If these side lengths are lowercase m, then this side length is going to be lowercase m as well. And here's our next step. We have dropped this perpendicular from this point D onto this line AB, as you can see over here. And here's our next step. Let's focus on these two right triangles AFD and this right triangle DEC. And now we can see that these two right triangles are our congruent triangles according to side angle congruency theorem. Since one of the angles is 90 degrees, this angle is 6x, and likewise this angle is 6x and this angle is 90 degrees. And moreover, this side length is m and this side length is m as well. And since these two triangles are congruent, so therefore this side length is going to be equal to this side length. This side length is a, so therefore this side length DF is going to be a as well. And here's our next step. Let's focus on this right triangle BFD. And we can see that this side length DF is A, and this side length BD is going to be A plus A, that is going to make 2 times A. So therefore our side length DF is A and BD is 2 times A. And now let's recall this 30, 60, 90 special triangle, as you can see over here. And in such kind of right triangle, if the longest leg is 2 times this smallest leg, then the angle opposite to this smallest leg is going to be 30 degrees. And now we can see that this is our smallest leg, so the angle that is opposite to this one is going to be, this angle is going to be 30 degrees. So therefore this angle DBF turns out to be 30 degrees. Now let me show you an alternative approach by using a SOHCAHTOA. Let's assume that in this triangle BFD, this angle is theta. then this side length is going to be our opposite, and this longest leg is going to be our hypotenuse. So therefore we are going to use sine of theta, opposite divided by hypotenuse. And we know our opposite side is a, and our hypotenuse is 2 times a, since this a plus a is going to make 2a. So thus our sine of theta is going to be a divided by 2a. That means sine of theta equals to 1 divided by 2. In other words, theta is going to be equal to sine inverse of 1 divided by 2. And if we use a scientific calculators, our angle theta is going to be simply 30 degrees. So no wonder this angle theta is 30 degrees. And now let's go ahead and make an observation. We know that this whole angle is 9x and this angle is 30 degrees. So therefore this angle has got to be 9x minus 30 degrees. So therefore this angle DBC turns out to be 9x minus 30, as you can see over here. And here's our next step. Let's focus on this triangle BCD. And we know that this is an isosceles triangle since this side length equals to this side length. So therefore this angle has got to be equal to this angle. If this angle is 9x minus 30, this angle has got to be 9x minus 30 degrees as well. Now let's recall triangle sum theorem. The sum of 3 interior angles in a triangle is always 180 degrees. Therefore in this triangle BCD, sum of all these 3 interior angles must be equal to 180 degrees. So let me go ahead and add up all these 3 angles. Let me go ahead and write down 9x minus 30 degrees plus 12x plus once again 9x minus 30 degrees, and that should be equal to 180 degrees. Now let's go ahead and combine the like terms on the left hand side. So that is going to give us 30x minus 60 degrees equals to 180 degrees. Now let's go ahead and add 60 degrees on both sides. This is gone. So on the left hand side we got 30x equals to 240 degrees. And now let's divide 30 on both sides. This is gone. So therefore our x value turns out to simply 8 degrees. So thus our angle x turns out to be 8 degrees. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.